This video is a tutorial for the lab titled Friction Coefficient Between the Shoe and the Floor. The objective of this lab is to find the coefficient of friction, which is mu s, between your shoe and the floor. So let's start with defining coefficient of static friction. We know that mu s is a ratio of Fs max over Fn. Fs max, is the limiting friction, and Fn is the normal force. So if we can measure limiting friction and the normal force, then we could find this ratio, which will give us the coefficient of static friction between the shoe and the floor. So the question is, how will we measure the limiting friction? So before we get to that, let's draw a free body diagram of the shoe when it is on the floor. So what are the forces acting on the shoe? Of course, there is gravity always, and it is acting straight downwards. So represent that by Fg, which you can always find as the mass of the shoe times g, whose value is 9.8. What other forces do you think act on the shoe? Yes, the shoe pushes down on the ground, so the ground pushes it back up, and that is what we identify as the normal force. And because the shoe does not have a vertical acceleration, the normal force must equal the force of gravity. Then you are trying to pull the shoe this way, so this is your pulling force. And you are pulling until the shoe is just about to move. So when the shoe is just about to move, what is the force that is resisting your pulling force? Correct. That is friction. And we know that because the shoe has not moved yet, it is still in equilibrium. That means your friction must be equal and opposite to the pulling force. And because the shoe is just on the verge of motion, that means friction has maxed out in the system. So therefore, we must correctly represent the friction as the maximum static friction, which will be equal and opposite to your pulling force. So this gives us a way to measure our pulling force or our limiting friction. So Fs max can be measured as your pulling force when the shoe is just ready to move. So that means in the experiment, you are going to put the shoe on the floor, hold a spring scale, attach a spring scale to the shoe, make sure the spring scale is perfectly horizontal, pull on the spring scale until the shoe is just about to move, and when it is about to move, read the spring scale. That should give you the value of Fs max. So we got that figured out. So how will we measure the normal force? Take a minute to think. So the normal force is equal to the force of gravity. That means if you measure the force of gravity, which is the weight of the shoe, then you can measure the normal force. So you can measure the weight of the shoe simply by holding it up using a spring scale. So if this is your spring scale, you can just hold the shoe up like this and read the newtons on the spring scale, which gives you the weight of the shoe directly. Alternatively, you can put the shoe on a mass scale, determine its mass, and then multiply by 9.8 to get the weight of the shoe. So now that you know both Fs max and Fn, you can get the mu s value. But in any good experiment, we want to do multiple trials so that we can get an average value of the constant that we are trying to determine. So that means we want to repeat multiple trials by varying the normal force. How can you change the normal force on the shoe? You guessed it right. We are going to add some weights into the shoe, thereby making the normal force on it larger. So if you look at the data table in the lab, you will find that you have 6 rows in which you could add weights to the shoe, thereby increasing the normal force, and for each value of normal force you find the Fs max. And then in the last column you can get the ratio of Fs max to normal force, and you can average all of this. There is also another way to represent your data, which is by drawing the graph. You could draw a graph between the normal force and Fs max. Because the normal force is your independent variable, it goes on the x-axis and Fs max goes on the y-axis. Take a few seconds to think about what type of graph would that represent. What would the plot look like? If you guessed it would be a straight line, then you are right, because look at your equation. Fs max equals mu s times Fn. Does this not look like the equation of a straight line, y equals mx? So now you can find out by matching the two equations, what does the slope m represents on this graph. I will leave you to figure that out, because that is your answer for the objective of this lab. So to summarize, find the least force required to move the shoe, read it, and that gives you your Fs max. The normal force on the shoe is the weight of the shoe. The ratio gives your mu s. You can do multiple trials by adding weights into the shoe and changing the normal force, record everything. And then when you want to plot a graph, there is also an Excel video tutorial available. So you can go ahead and plot the graph on Excel, or else you can draw it on paper and take a picture and put it in, or else you can just input grid paper right on this page, and then you can complete graphing. But always remember to follow good graphing guidelines, and this is a lab, so representing data to correct precision is very important. So good luck on completing the lab.